This video is to help you understand how to use your calculator to be able to find a derivative at a point. Okay, so I have both calculators, and just depending on which calculator version you've got. So the function you can see is 3x squared minus 4x. So we'll type that into the y1, either one, and then just go ahead and hit graph. So I'll go back to the y equals. So pause the video, get this in here, and type in zoom 4. Zoom 4, your graph should look just like this. And as you notice, somewhere between 0 and 1, we see that that you've got a vertex of the parabola, and at the vertex of a parabola, the derivative is equal to 0. And then to the right of that point, you can see the derivative would be the slope of the tangent line. Anyway, we're going to be finding the derivative when x is equal to 1. Okay, so when x is equal to 1, you might even be able to do this in your heads. If you mentally picture the derivative of this function, it would be 6x minus 4. And I know I'm doing this a lot in verbally, but anyway, 6x minus 4. So when x is 1, you should get 6 minus 4, or 2. So 2 should be the solution that we get when we evaluate the derivative at 1. Okay, so the way we do this is Math 8. Math 8 is n-deriv. Okay, and the right side calculator is the one that's the older version, but n-deriv, you're supposed to put 3 numbers in there, or 3 entries in. First one would be your y1. So the vars, y variables, enter, enter. So that's your y1 value. Okay, and then comma x, comma 1. I said so. 1 is going to be the derivative where we want to find the derivative. Okay, and so that's it. You get 2. So the 3 entries are the function, comma the x, comma the real number that we want to find the derivative at. Where do we want to find the slope of the tangent line? It's that third number. That's the third entry. You could also use your the book that came with your calculator to verify that, but nevertheless, that's how you do it. And on the left-hand side calculator, we see we've got more of a user-friendly version in which the x is always going to go down there in that spot. And then what are we taking the derivative of? Well, it's easy to remember what to put in certain places, because this notation indicates that we're ddxing what function? Well, the function is vars, right arrow for y variables, enter, and then you have to select the function that you've already defined it to be. And we've already defined our y1, so we're going to hit enter as our function 3x squared minus 4x. Right arrow gets us over to, well, where do we want to find this derivative? We want to find the derivative at x equals 1. And once we type in a 1 there, we can just hit enter, and we see again we get the derivative of y1 is equal to 2. If by chance you wanted to see what the derivative was at a different x value, you don't have to go back through that whole scenario. By the way, let's look at the graph. The derivative at x equals 1 is 2. As we move, as x gets bigger, maybe it's intuitive, maybe not, but as x gets bigger, the slope of the tangent line also increases. So you can see that basically the graph gets steeper and steeper, which means that the tangent lines will have greater and greater slope, okay, as you move to the right. Anyway, we could do that. We can go back to this screen, so back to the home screen. If we wanted to type in a different value for x, you'd want to hit second entry. Entry is the enter button. Hitting the second key first, we see that we can call up the entry, meaning that we will just be able to change the values in that last entry that we typed in. And so the derivative of y1 at, let's say, x equals 2. That should be a bigger number. Okay, second entry again, and let's change the 2 to a 3. You can see the numbers get bigger and bigger. As x increases, the derivative also increases. So second entry, left arrow, and we'll change that to a 4. You can see they increase by 6 every single time, because remember, the derivative is 6x minus 4. So if the derivative is 6x minus 4, slope is 6, so the derivative is a, oh, I already did 4. The derivative is a linear function. 26, second entry, left arrow, type in a 6, and it should be 32. Because the derivative, as x increases by 1, the value of the derivative increases by 6, because the derivative is 6x minus 4, so it has a slope of 6. X increases by 1, y increases by 6. So that's how you find the derivative using your calculator. Let's try to find another one. Go ahead and change the 3x squared minus 4x. Let's just change that to sine of x. Okay. First of all, make sure you're in radian mode. Okay. And type in to your y1 sine of x. And interestingly enough, see if I can predict what this derivative is going to be. So here we have zoom 4, and what you should notice is that, well, maybe this is not intuitive, but at the origin, the slope is, looks like it might be 1. At pi over 2, the slope would be 0. But let's just test that out. It looks like it's about 1 right there at the origin. So what we want to do is we want to find the slope at 0. Okay, so if we type in math 8, and we still have, and this is interesting too, watch this, second entry, the y1, we just changed the y1. We don't need to go back, and we don't need to do anything. We don't need to type in the math 8 anymore. We can just change the y1, change the y1 in the y1 screen menu, and then we go back to this guy right here, and we hit enter, and find the derivative of y1 at x equals 0. Now again, your calculator is going to give you an approximation, but when you do round that number to the nearest 3 digits after the decimal, you do get 1. So the derivative is 1 at x equals 0. Okay, and so again, you can do the same thing with the other calculator. Y1, instead of being, make sure in radian mode, instead of being the other function, the quadratic, we're going to go sine of x. So the sine of x, again, second quit that, and second entry, all we're doing is changing the 1 here to a 0, and we get, again, a value that when rounded will be equal to 1, and so we would round that to the nearest 3 digits and we would get 1. Okay, so that's how to do it. We could change it to cosine, second entry. Cosine at 0 would be 0. Look at the cosine graph. Cosine has a slope of 0 when x is 0. You look at a sine graph. Sine graph over here, the sine graph has a slope of 1 at x equals 0, and the cosine graph has a slope of 0 at x equals 0. In fact, what is the equation of the line tangent to the graph of y equals cosine x? What's the equation of the line? Well, the equation of the line would be y equals 1. So if you graph that, there you go. There's your tangent line, y equals 1. Well, what's the equation of the graph of the, what's the equation of the tangent line to the graph of sine of x when x equals 0? What's the equation of the tangent line? Well, we know the slope is 1. Slope is 1. X and y coordinates are 0 and 0. So we have y minus 0, which is y, equals slope of 1 times x. So you have y equals x. So if you have y equals x, we see that, graphing that guy, there's the tangent line at x equals 0. So this is kind of cool. You know, you can manipulate your functions, and you can find your equations of your tangent lines, and then you can graph the tangent lines at those certain values. So anyway, Hopefully that helps. You can experiment with all kinds of different functions. In fact, when you're finding derivatives by hand, use that opportunity to type those functions into your calculator so you can practice finding equations of tangent lines on your calculator. Okay? Or sorry, derivatives on your calculator, and then you can find equations of the tangent lines by hand using your Algebra 1's super skills. Alright, I think that's about enough. It's 11:30. I'm tired. Going to sleep. Have a great night.